Good morning, ladies and gentlemen. Your host, Golden Zulu. So today we have one interesting subtopic under differentiation, which is first principles. But with us, with first principles, this is the formula that we'll be going to use. So when you are dealing with the first principles, each and every time you use the same formula. Then with us, we have one interesting question, which is the function equal to x squared. So we are told to say we should differentiate this. So for us to differentiate that, we will just get the formula and replace. So we have x to be the letter which was with the function, where to this x we will attach h, then we square it, minus the function in this case is x squared, which we will also attach over h. Then from here we will expand this and simplify, and you will have x plus h minus x squared over h, where x times x is x squared, x times xh is xh, plus h times x is xh plus h squared minus x squared over h. Having done that, we will now simplify this because those are like terms. So x squared, this and that, they will give us 2xh plus h squared minus x squared over h. Then from here, x minus x is 0. So you will remain with 2xh plus h squared over h. Then from here, you will factorize the h because it is common. So let one h come outside, and you will have 2x plus h over h, where h and h can cancel, and you will have 2x plus h. Then one thing you should know, when you look at this expression, you can no longer go down further, but in our differentiation, we should never have an h. So what comes in your mind? When dx is approaching the x-axis, it is getting closer to 0. So we have 2x plus 0, where the differentiation of x squared using first principles is 2x. Thank you, your host, Golden Zulu. So guys, we continue. We know to say we have been told again to differentiate this using the first principles. So you always replace or add h to x. So we will do 1 over x plus h minus 1. Remember, there is no x, so we can't add plus h. Then you subtract with the original function, which is x minus 1 over h. So having done that, our main focus now, when you look at these in fractions, you will say common denominator. So you will say x plus h minus 1. So we can just pick this to be just 1 like this. Then x minus h. So this will belong to that, and this will belong to that. Cross multiplication. So this times that is just the same, x minus 1. Then negative 1 times x is negative x. Negative 1 times h is negative h, and negative 1 times negative 1 is positive 1 over h, like that. So having done that, we know to say x minus x is 0, negative 1 plus 1 is 0, so you have remained with negative h over x plus h minus 1, x minus 1. Then from here, this line here simply means division, and you will have h like that. Where you know to say this division will go to multiplication, and you will have something like this. Minus 1 here, x minus 1 multiplied by 1 over h. Don't ever tamper with the denominator, leave it like that. So h and h will cancel, and you remain with negative 1 over x plus h minus 1, x minus 1. Remember, we said when you only have remained with h, the x will always get closer to the x-axis, and this will approach what? 0. So you have negative 1 over x plus 0 minus 1, x minus 1. So from here you have negative 1 over x minus 1, x minus 1. Remember, these are the brackets of the same kind, so you will have negative 1 over x minus 1 squared like this. So this is the differentiation of that using first principles. Your host, Golden Zulu.